For the longest time, business analytics has been about looking in the rearview mirror, trying to figure out what happened yesterday. But what if we could flip that around? What if instead of just reacting to the past, we could start predicting the future?
Think about it like you're driving a car. Of course, you need to glance in that rearview mirror. That's your descriptive analytics. It tells you what you've passed, what's behind you. But to actually get where you're going, 99% of your attention has to be on the windshield. That is predictive analytics. And it's not just about seeing the road ahead. It's about anticipating the curves, seeing the traffic jam before you're stuck in it. This is the big shift, from simple hindsight to powerful foresight.
All right, so here's our game plan for today. First, we're going to pick the right forecasting engine. Then, we'll dive deep into the most important concept, the heartbeat of data. After that, we'll look inside Excel's crystal ball, learn how to map out risk, check our model's vital signs, and finally, build a bridge from just numbers to actual names. Sound good? Let's jump in. Okay, first things first. Before you even think about touching a formula, you have a really important choice to make. You've got to ask yourself one simple question. What kind of problem am I dealing with here? Is it a chef or is it a clock? This really boils down to the two main ways of thinking about forecasting. On the left, you have causal models. That's the chef. The final result, let's say a delicious meal, depends entirely on the ingredients you put in, your marketing budget, your price point, your product features. Those are your X variables. But on the right, you have time series models. That's the clock. A clock doesn't care about external ingredients. It tells you what the next second will be based purely on the rhythm of its own past.
It's so easy to fall into the trap of using a clock-based model when what you really need is a chef. For this explainer, though, we're going to put all of our focus on mastering the clock, the art and science of time series forecasting.
And this brings us to the absolute core of our topic today, the heartbeat of data. We have to understand the fundamental rhythm that makes all of this work. Without it, none of this is possible. Okay, I'm going to slow way down here, because this is, without a doubt, the single most important rule in this entire field. If you get this one thing wrong, everything else you do is a complete waste of time. For a time series model to have any chance of working, your data has to have a steady rhythm.
It has to be collected with a constant, steady
Heartbeat. I don't care if it's every second, every day, or every month. The time gap, the interval between each of your data points has to be exactly the same. Period. If it's not, you don't have a time series. You just have a jumble of random noise. This is the non-negotiable price of admission for forecasting.
So, once we've confirmed we have that steady heartbeat, we need to figure out what the data's made of. And the best way to think about this is like peeling an onion. This process is called decomposition. We start by stripping away the outer layer, which is just random error or noise. Then, we peel away any long-term, multi-year economic cycles. Under that, we find the next layer, seasonality. Think of your sales spiking every Friday. That's seasonality. And only when you've peeled away all those other layers do you finally get to the center, the core, the trend. That's the real underlying direction your data is headed.
And this right here is why this isn't just some academic exercise. This is real money. Imagine you see a huge sales spike in December. Without peeling the onion, you might think, wow, we're a rocket ship. You go out, you hire more people, you stock up on inventory, and then everything craters in January. You just mistook a temporary seasonal pattern for a permanent trend. This decomposition process is what protects you from making that incredibly common and incredibly expensive mistake.
Now, the great news is you're not going to be sitting there peeling this onion by hand. Excel has an unbelievably powerful toolkit that does all of this for you automatically. So let's take a look inside what I call Excel's digital crystal ball, the FORECAST.ETS functions. All right, I know this looks a little intimidating, but trust me, this is where the magic really is. The first three parts are easy. What date do you want to predict? What are your historical numbers? And what are your historical dates? Simple. But look at the optional stuff. That seasonality argument, you just set it to 1 and you're literally telling Excel, go find the rhythm for me. It's incredible. Then data completion. Got some missing data? No problem. As long as it's less than about 30%, this little setting tells Excel to intelligently fill in the blanks for you. And aggregation, a total lifesaver. If you've got 2 sales on the same day, this lets you tell Excel what to do. Add them up, average them out, you've got options. So, getting a number from our model is great. Awesome, we did it. But what does that number actually mean? How much can we really trust it? This brings us to a huge idea, assessing reliability using the flight path of risk.
So let's say our model spits out a number,
It tells us next month's sales will be 15,000 units. It's precise, it's clean, it feels certain.
But here's the million-dollar question every analyst has to ask. How much do we really trust this one number? Do we bet the farm on it? Do we staff our factories and order all our parts based on exactly 15,000 units?
To figure that out, let's use the flight path analogy. That 15,000 unit forecast? That's the perfect flight plan, drawn as a single neat line on a map. But we all know that's not how planes actually fly. There's turbulence, there's wind. The confidence interval, which we get from another amazing function, FORECAST.ETS.confint, is the buffer zone. It's not the single line, it's the entire wide corridor in the sky where the plane is realistically expected to be. It gives us a best case and a worst case scenario around our forecast.
And listen, this is where the rubber meets the road for any manager or budget holder. A nice narrow flight path means you have a reliable forecast, but a wide confidence interval, that is a massive, flashing red flag. It's your model basically screaming at you, hey, I am really not sure about this. When the stakes are high, you can't just budget for that single forecast number. You have to be ready to handle the turbulence, prepared for the high end of that range, but without going broke if you only hit the low end. It turns a simple number into a serious tool for managing risk.
Okay, so we've checked the flight plan, but now it's time to pop the hood and check the engine itself. We need to see if our model is healthy, and we do that by decoding its vital signs with yet another function, FORECAST.ETS.stat.
Think of this function as the mechanics diagnostic report for your model. It gives you 8 key statistics. The first 3, alpha, beta, and gamma, tell you how the model is thinking. Then you get 4 different error metrics that tell you just how accurate the model has been in the past. And finally, number 8 confirms the step size. It tells you what heartbeat it detected in your data.
Let's start with alpha. This one controls how the model sees the base level of your data. To put it simply, a high alpha value means the model has a really short memory. It's paying a ton of attention to the most recent data points, basically assuming that whatever just happened is the best clue for what's about to happen.
Then we have beta, and this is all about the trend. A high beta means the model is super reactive to any change in the trend's direction. So if sales have been climbing for months but took a small dip last week, a high beta model will slam on the brakes and immediately start leveling out its forecast. It's very sensitive to that most recent movement.
And finally, there's gamma, which is for seasonality. A high gamma tells you the model thinks the pattern from the most recent season, let's say last year's holiday season, is the absolute best predictor for this coming holiday season. So let's just recap these vitals. A higher alpha, a higher beta, or a higher gamma. They all mean the same basic thing. Your model is giving way more importance to what just happened recently.
All right, we have covered a ton of ground. We've figured out how to choose a model, we understand the critical importance of the data's heartbeat, and we know how to build, stress test, and diagnose a forecast right inside Excel. So now let's build a bridge to what comes next. Let's talk about going from numbers to names.
So everything we've talked about up to this point, that's forecasting. It's all about answering questions like how much or how many. It gives you a number, but there's this whole other universe in predictive analytics called classification. And that's about answering questions like which one or what kind. So forecasting predicts we'll sell 15,000 units. Classification predicts which of our customers are the most likely ones to buy. See the difference?
And that really sets the stage for our journey forward. We've gotten really good at predicting the numbers, the sales figures, the web traffic, the inventory levels. So the next logical question has to be, how do we take that ability and start sorting things into useful categories? How do we go from predicting the quantity of something to classifying its nature? That's the next frontier, and that's exactly where we're going next.